This is question 9 from the homework booklet. There's quite a lot going on in this question, so I'll talk you through it. Tritanopia is a form of colour blindness caused by a recessive allele. Diagram below shows the inheritance of tritanopia in a family. You can see the pedigree here. Unlike other forms of colour blindness, tritanopia is autosomal and not carried on the sex chromosomes. It is caused by a recessive allele. Here, give one piece of evidence that tritanopia is not sex-linked. So when you're asked to give one piece of evidence, you just need to state the two parents that would prove that it's not sex-linked. So parents 1 and 2 could not produce offspring 3. The reason for that is if it were sex-linked, the female would have to pass on X chromosome to the male offspring 3, and therefore the male offspring 3 would receive the recessive allele and therefore the tritanopia phenotype. So the evidence for this, 1 and 2 could not produce 3. Another piece of evidence would be 5 and 6 could not produce 8. Okay, so next question. What is the probability that the next child born to individuals 5 and 6 will be a boy with tritanopia? So, from this pedigree we can see that 5 and 6 must both be heterozygous. Or, let's say. Therefore, there would be a 1 in 4 probability that their children were had the condition tritanopia. But to find out the probability if it was a boy, that 1 in 4, that 1/4, must be times by a half to find out if they're male or female, or male in this case, which equals 1/8. So the probability that the next child born will be a boy is 1/8. Okay, next, it gets a little bit more complicated. So Alport syndrome is recessive and X-linked genetic disorder characterised by kidney disease and hearing loss. A man who is heterozygous for tritanopia and does not have Alport syndrome has a child with a woman with tritanopia and is heterozygous for Alport syndrome. So use a genetic cross to determine the probability that they will produce a boy with Alport syndrome and tritanopia. Okay, so the genotype of the parents then. Firstly, the man, heterozygous for tritanopia. So, 1 dominant allele, 1 recessive allele, and does not have Alport syndrome. We know that it's X-linked, and recessive, so therefore you must have an X chromosome with the dominant form of that allele, and also, of course, a Y chromosome. The mother, or the female, has tritanopia, so therefore homozygous recessive for tritanopia, and is heterozygous for Alport syndrome. So, 1 X chromosome with the dominant allele, 1 X chromosome with the recessive allele. Possible gametes for these parents would be, in the male could produce dominant for Tritanopia, dominant for the Alport syndrome, and if you put the gametes in circles, following the convention there, they would also have dominant for Triport and a Y chromosome, recessive for the Tritanopia, and the dominant for Alport, and finally recessive for Tritanopia and a Y chromosome. The only two possible gametes that the female can produce would be recessive for Tritanopia with a dominant allele for Alport syndrome, and then recessive Tritanopia and a recessive allele for Alport syndrome. Okay, so from that we need to draw a genetic cross diagram to calculate the probability, determine the probability that will produce a boy with both Alport syndrome and Tritanopia. So if we draw our genetic cross diagram, we can actually, in this question, I think there's a mistake in this question booklet, we can ignore this for now. We have the two female gametes, so and then the four male gametes. Complete that table. So, producing a boy, so going to be XY, with both Alport syndrome and Tritanopia. So they must be homozygous recessive for Tritanopia. So the only combination can be this one down in the bottom, right hand corner. So homozygous recessive for Tritanopia. And a boy with Alport syndrome, so therefore they must be XA, Y. So the probability then that they'll produce a boy with Alport syndrome and Tritanopia is 1/8. Okay.